Welcome back. So let's conclude our series on Django Middleware by covering the asynchronous supports. Once you create your middleware in Django, by default, your middleware can only support synchronous responses. By that I mean if your view, which is the request handler, can only return a synchronous response, your middleware may pass on those responses to different subsequent middleware in your middleware configuration. There might be a situation where you want to handle asynchronous responses from different requests and handler in your Django project. So in that case, you need to instruct your middleware to handle both synchronous response and the asynchronous response. To do so, we have some provisions how this may be applicable. If you build your Django middleware using a class-based constructor, you can either apply the attributes, as you can see on the screen, the sync capable, and set that to true, which means your middleware will only handle synchronous responses. If you set another property, the async_capable set to true, that means that you can only handle async responses in your middleware. That implies that if your middleware in the middleware list configuration has to pass on the response with another middleware, it can only pass the async responses. There is also an alternative if you don't want to set the two property, the sync capable or the async capable on your class-based constructor. You can also apply decorators from Django. You can either use the sync and async middleware, which is the one we're gonna be demonstrating in this video. When you apply the sync and the async middleware decorator on your class-based constructor, your middleware will be able to separate responses. You know, when the response is of type when your response is a synchronous response, your middleware should be able to handle the synchronous response or the async response. If you only apply the sync only decorator on the class, as you may guess, your middleware will only handle the synchronous response. So let's go on the demo and demonstrate how we can apply or support the asynchronous response in our middleware. See you in the demo. Let's make our middleware to support the async response as well as the synchronous response from our view handlers. To do so, we need to import the decorator from Django util.decorators. We need to import the sync and the async decorator. So why should we import the sync and the async decorator? We wanna automatically set the two property in our middleware. Those are async capable, which should be set to true, the sync capable. So setting these two attributes doesn't mean that Django will automatically handle sync and the async responses from the request handler, our views. We wanna instruct or tell Django exactly by branching, checking the get to response and handling different responses type, like the synchronous response and the async response. So we're not gonna apply that manually. We need to use the decorator that will automatically inject these two properties. Let's apply our decorator sync and async middleware by applying this decorator on our class async middleware. Automatically the two property will set and Django will wait for different conditional inside or within the middleware so it can handle different types of risk. Now we have built our middleware using a class-based constructor. There is also a provision out there in Django documentation, you can create your middleware constructor using function-based style. But so now that we have a class-based constructor, we need to make sure that we tell Django, when to handle different types of response. If our get response is of type, if our get response retain a synchronous response, which is a blocking response, or the async, which is a not blocking response, how should we do that? Let's start checking our get response, in our init. So if our get response is a coroutine, by coroutine we mean that if our get response is a async, we need to make sure that our middleware, we will wait for the response before we retain the response. So to do that, we can import the asyncio module, which is already loaded, imported here. So asyncio is a coroutine function get response. We're checking if get response, which is a preceding or the current response. If get response is a coroutine, which implies that this response is coming from the async view, not from the regular view. If that is the case, we need to, let's create a function. We call that function middleware, and that function will be the async function, and we pass it the request. This function is sort of a helper that will, branch results according to the type of the response we're getting from our view. Response equal await get response, and the get response, we take the parameter the request and will return response. Okay. If our get response, if our response is just like a synchronous response, in that case we just need middleware to be a regular function, and the response will be from get response, which takes in the request, and then we retain our response. So what's the next step? As we know, in Django middleware, it receives the get response, which symbolize the subsequent or the current response. We have the call that will call the get response, and the call get response, which run our get response. So in this case, we don't need a get response, since before we call our middleware, let's create a global property in our class. Let's call that middleware equal middleware. We pass the function middleware in our init or constructor attributes middleware, and then we don't need the get response anymore, since the get response is being modified from the middleware. So we're gonna call self middleware, and we pass in a request, as we are passing a request here to handle different types of response. We still have our response if response is streaming, which is different than the async. The async response retain a coroutine, but the streaming response retain a coroutine of byte strings. So that's one thing we need to make a demarcation between the streaming and the async. Okay, so that's pretty much what we need to instruct our middleware to handle both the synchronous response and the asynchronous response. Let's run our server and test it out and see what's gonna happen. Okay, now our server is running. Let's see. We should have the async request handler. We don't have any async request handler. Let's create a async simple async request handler. We call that the async home, or that async home takes in a request. The async home takes in a request and return the HTTP response. And so what do we want to return here? We can just JSON dump some JSON data here. JSON dump, we pass the dictionary, cross JSON is now fine. We put JSON. Let's name the key data and then the value, some content type, application, JSON. Yeah. We set our content type literally so that whoever will be in charge of this particular data on the front end, they can, get the header or type or content type from the header of this response. Pretty much, that's simple. That's all we need for this simple async request handler or view, as Django calls it. Let's go back on our URL configuration and create a new URL. Let's name that async home. This we need to import async home. Just we pass it. Of course, we need the /path so we can determine which one gonna be the last query parameter or the next path. Okay, we have our path async home. It should be fine now. Let's try to check it. Localhost set 1000 v1.0 policy async home. There we go. So we get some data, and this is the JSON objects from the async view. And yeah, that's the way we can instruct our middleware to handle both the async response and the synchronous response. When we apply decorator async and the sync and the async decorator that sets property automatically, injects property automatically in our async middleware class. Now, so how can we make sure, how can we confirm that this view, which is of type coroutine, how can we know that this view is being handled by this logic? Or if async IO is coroutine function gets response, and the gets response is the response from our view, and then it waits from the response, while the gets response takes in a request. How can we confirm that? Because if we go back on process view, after verifying that the process view is either a function or it's a class-based view, and then we check the property if it's a function on a class-based view. How about we just return the view by passing the request? Let's just return the view and pass the request and see what's gonna happen. Go back, refresh. Oh, now we got an error here. It says the view policy async home didn't retain a HTTP response object to retain the unawaited coroutine instead, which means that this view this view we call here, will return here is a coroutine view. It's not just a simple function. It's a coroutine function. And but if we remove that, if we don't call that, which means in process view we are not doing anything, you know, the default logic apply, it will automatically just skip this implementation because we are not calling the view before, or we are not calling the process view before the view is called, which means the view is being called here. Let's refresh. So we go back to our view responding with JSON data. If we wanna at the same times manage the async response and apply the async response on the process view, we will need to do some logic, something like after checking that the view is either a base class view or it's a function. If it's a base class view, check if it has a attribute can send email. We can also check by using asyncio, check is a coroutine function view, which means if our view has a a syntactic sugar async, if it's a async, and this will return true for this for the async home view. So if it's a coroutine function, what should we do? Remember, a coroutine function can only be run on it can only be awaited, it can only be awaitable. So which means we can do something like a loop equal async io, creates a new event loop. In our async io, we set the event loop, and we run our loop, run until completes view request. So this is where our async will run in the process view. To verify that, we can print this is an async view. If not, we just retain the view and then we pass it the request. Of course, we have to return the loop here until complete. We'll return that, and then it's gonna GC that, it's gonna garbage collector once it's complete. We don't have to close the loop here. It's gonna do that automatically. Yeah, so that's the way we can verify. Let's try it out and see what's gonna happen. So if we run again, as you can see the message, this is an async view, which means the view we just ran was an async view. Surprisingly, the process view should adapt the type of response you are getting in your middleware. If the response is a async response, you want to make sure that you enter that properly, correctly, should have said, enter that correctly in your process. Oh, that's all for the Django middleware. I know this series was a little bit not the beginner side, but I wanted to go through different concepts uh, while creating a Django middleware. You know, in this series, we've covered the process view, which is a hook in the Django middleware framework that is called before the view is called. So this one is called before the view. We've covered the process exceptions that catch the exception from the view, the process template response that will render a response of type template response. Yeah, that's the way you can create your Django middleware without also we've covered also the sync and async middleware. Yeah, so if you've missed any of my video about creating a Django middleware, check out my channel, go through all the video. You will see where I cover the process view or the process exception, the process template response, and then yeah, that's all for Django middleware. Thank you for watching. I'll see you in the next one. I think in the next one I will demonstrate and talk about how you can test a async application in Python. From now, I'll put a break on Django and I'll talk about Python in general. I'll see you in the next